So let's start the demo, and these are the demo steps that you have to do. What we need is we'll be creating a Kubernetes cluster with three nodes, one master and two workers. And we'll be setting up the servers. It can be your local machine. I mean, it can be multiple virtual machines on your local system. It can be either EC2 instances or Google Compute Engine instances. So once the servers are up and running or the virtual machines are up and running, we'll have to install Docker on all the machines. And these are the steps to install Docker. Don't worry, you'll find all the commands in the resources section. But remember one thing, that instead of copying and pasting the commands, when you practice, type the commands. That'll be better because there might be some unnecessary characters when you copy and paste it. So I would suggest, even though you get the documentation or the commands list from the resources section, please type the commands as you go. Do not copy and paste. So after installing Docker on all the machines, I'll have to install kubeadm, kubelet, and kubectl. So kubectl can be either only in the master because it does not need to be on the worker machines. Typically, kubectl would be installed on the machine where you want to run the Kubernetes commands from. So it can be your local machine also, or your office desktop. So after that, you have to make sure that certain things are done. We have to disable swapping. All these commands are mentioned in the resources section, or whatever PDF document you download, or the PDF document will have all these commands. So let us go ahead and install Docker first. Then we'll install kubeadm and kubelet and kubectl. So this is the first server or virtual machine which I'll be using to install all the components that I have shown you. Now this is a Red Hat Linux server, if you see, and I'll be doing all the exercises or all the demos on Red Hat server only, or Red Hat operating system, sorry. I have named this server as K8S master or Kubernetes master. So this server would be the master node. The first thing that I have to do is I'll have to upgrade the machine. So the upgradation is done. Once that is done, as this is Red Hat, I'll have to include the EPEL release. You already know this. We did this in the Docker lab. It says that the EPEL is already installed. Then we'll have to install something called device mapper. This is not necessary, but sometimes you might get error. So you might want to run this command as well. So this is the command. Run this command. It should not take much time to complete. Once that is done, we'll have to add the repository. So you already know how to do that. The repository has been added. Now I'll install Docker on this particular machine. So Docker installation is complete. So we have Docker version 18.09 installed. Now the next step would be to install kubeadm, kubelet, and kubectl. But to do so, the first thing that you have to do is you have to edit this file. Basically, you'll have to create this file to add the Kubernetes repository. And after that, you have to add these lines. I have already mentioned all these in the PDF file. You can find it there. Once that is done, we'll have to disable AC Linux. So after this command, the AC Linux has been disabled. We have to disable swap also. So now we'll be installing kubeadm, kubelet, and kubectl. So this is the command to install kubeadm, kubelet, and kubectl. I have put all the commands in the PDF file so that I can use it. So press enter and it should go ahead and install kubeadm, kubelet, and kubectl. So all the commands or all the utilities have been added. Kubelet, kubeadm. You can type the tool and -- help. It will show you the output. Similarly, kubelet also. So all the utilities are done. Then we'll have to start kubelet. The way you do it is using this command. Sorry, it should be kubelet. So once it is enabled, we are ready with all the utilities that we need. And the same things have to be done in the other nodes also. So I have done it in the master node. I'll be doing it in the two worker nodes also. But before that, there's one more file that we have to change, which is this one. K8S.conf, this file has to be modified, and whatever is needed inside of this files is also there in the PDF document. So these are the two parameters which you have to set up. These are for IP tables, IPv4 and IPv6. And once it is done, we'll have to run a few more commands. So we'll have to start system control. Then we have to add something called net filter, br net filter. So how do you know whether it has been added or not? Just type ls mod command and followed by grep, and if you get some output, that means it has been installed. So this is done. Now all these steps have to be executed in the other nodes also. So I have run all the steps in all the nodes that I have. As I said, I have 3 nodes, and now we are done with the first step. So basically we have installed Docker on all the nodes. We have installed kubeadm, Cubelet and kubectl on all the nodes. We have disabled swapping. We have also disabled AC Linux, or we have set the permissive mode as on. Now, as I said, all these steps can be found in Kubernetes documentation, but it's better to put everything in a single place. So that's why I have created that PDF document, which you can find in the resources section. As all the components are up and running on all the 3 nodes with 2 GB of RAM and 2 CPU cores, the next step is to create the Kubernetes cluster. So I have 1 master and 2 worker nodes as of now. So what I have to do is, all these machines are sitting idle. They do not know that they are part of Kubernetes cluster yet, because we have not done anything yet. What we have to do is that we have to stitch them together as a part of Kubernetes cluster. So we have to make sure that the master knows that it is the master of a Kubernetes cluster, and also the worker nodes know that they are part of the same Kubernetes cluster. To do so, we have to use the kubeadm command. So the first thing is kubeadm init. So this command, which will be run, we have to run this command on the master node. Now the master node can be anyone, but wherever you run this command, kubeadm init, that node becomes the master node. If you had run this kubeadm init command here, then this node would have become the master node. So once it is done, you have to go to the worker node and you have to run the kubeadm join command. The moment you run this command on a worker node, this worker node is joined with the master node, and they too become part of the same Kubernetes cluster. Similarly, we have to run the kubeadm join command on the other worker node, and the moment we do so, that node also becomes part of the same Kubernetes cluster. Now, if you want to add more nodes, you can add more node and then run the kubeadm join command, and then that node would be added to the same cluster. So basically, we'll be using this setup. We'll be having 1 master and 2 worker nodes. So let us go ahead and do so. What I'll do is I'll log into the master node and I'll run the kubeadm init command. And this is my master node. So start the Docker service using this command, sudo systemctl start docker.service. After starting the Docker service, you can check whether the Docker service is actually running or not using this command, sudo service docker status. Notice that most of the commands that I have run, I have used the sudo. I have run those commands using sudo because you need root permission, or else you can log in using root and then run all those commands. I'm using Google Compute Engine instances, and the same would be true for AWS EC2 instances also. So now, as the Docker service is running and all the machines and all the installation are done, what we'll do is we'll start the kubeadm init command in the master node. So this is our master node, and now I'll have to start, or I'll have to mention the kubeadm init command. And this is the command sudo kubeadm init dash pod network cider. The pod network cider is the network address or network address range for all the pods. Now, what is a cider range? If you do not know, don't worry. I have put a video of basic networking concepts in the last section of this course. Now you can go through it and come back and see what is a network cider. But here I'm mentioning that the network address range for all the pods would be 10.168.0.0/16. and the first 16 bits belong to the network. So all the pods would start with the IP address 10.168 and then followed by something else. So let us go ahead and run this command, and it will take some time for this command to get finished. So now you can see that all the stages, first was the pre-flight stage, which pulls some images from to create the Kubernetes cluster. Then it starts kubelet. It writes kubelet environment file in var live kubelet kubeadm -flags.env. Then it creates some certificate. Then it does some kube configuration, and after that it is done. So now it says that the control plane has been initialized successfully. So you already know what a control plane is, which is the master node. So as we have initialized master node using the kubeadm init command, we have the control plane ready. But if you want to use this cluster, we have to run a few more commands. First commands are these. So it is already mentioning that run the following three commands using a regular user. Now if you do not run this command, what will happen is you won't be able to run the kubectl command and it will give you error. So I'll run these three commands right now, and I have run all the three commands. Let me try to run the kubectl command. So it is showing there's only one node, which is K8S master, whose role is master, but it is not ready. The reason it is not ready because the networking has not been provisioned yet, and we also have not joined any worker nodes. To join worker node, you have to use this kubeadm join command, which has been mentioned here. But before doing so, we have to set up the network plugin. The reason we need to set up network plugin so that the kubelet process in the worker node can talk to the master node. So until unless we set up the network plugin, the worker nodes will not be able to communicate to the master node. So that is the first thing that you have to do after you initialize the control plane. But make sure that you keep this command, kubeadm join command, handy and keep it in a safe place because it will be needed once the network plugin is done. And basically you'll have to run this command on all the worker nodes. In our case, there are only 2 worker nodes. And this is the command that you should run to install the Flannel plugin. I have provided the command in the documentation of the resource section, so you can copy and paste that. So once you press enter, it should say that Flannel has been created, so on and so forth. The reason we had to install Flannel because Qbm does not provide any network solution. In fact, it does not install any network solution as well. So we have to use the CNI or container network interface, which is a container or and Kubernetes compliant network solution, and we have to use some plugin or the other. We have used Flannel here. If you want, you can use Calico also. Remember one thing, you do not have to worry about this networking thing when you are using cloud services because those are managed services and all these things are provided to us. As we'll not be using kubeadm when we work either using EKS or GKE, these things will already be provided and you will not have to bother about the network plugin anymore. So now what we have to do is, as we have installed Flannel network plugin also, we have to use the kubeadm join command on the worker nodes. So I'm in the first worker node and type this command. Sorry, you have to run it as root. So sudo kubeadm join command. And what it is going to do is it is going to add this node, which is worker 1, K8S worker 1 in the cluster. So we had 3 nodes. We had one control plane, but we did not add any worker nodes in the cluster. So using this kubeadm join command on a worker node 1, once I run this node has been added to the Kubernetes cluster. The same thing will be done in the worker node 2 as well. So if I run the same command, sudo kubeadm join, which is provided by the output of the kubeadm init command. So once I press enter, now this node has also been added in the Kubernetes cluster. Now our Kubernetes cluster has 3 nodes, 1 master, 2 worker. And if you want to see the status of the nodes, you can run this kubectl get nodes command on the control plane. That means you have to run this command on the master node. Now I am in the control plane or in the master node. If I run kubectl get nodes command, let us see what is the status. Now it is still showing that the status is not ready. Now if you want to troubleshoot this, you can run the command kubectl describe nodes. So let us go ahead and see each and every node, what is the problem and what is happening. First, I'll try to describe the master node, And note the name of the master node, which is K8S hyphen master. This is the host name. So I'll have to use the same name in the describe command. So this is the command kubectl describe node followed by the node name, and let's see what it says. Everything is fine, everything is up and running, but there's something called the runtime network not ready. So it is saying that network is still not ready. Reason CNI configuration is uninitialized. And here everything is normal. So if you see the events, all the events are normal. Let us try to see the same thing on one of the worker nodes. So in the worker node also it says that network ready is false, reason that the network plugin is not ready. And what about the events? Everything is fine. Kube proxy is being started. There's no memory pressure, no disk pressure, etc. So there's some error in the Flannel plugin. So what we'll do is we will use a different command to install Flannel, and then we'll see whether it works or not. So the reason it is not working because I'm using an older version of Flannel, which is not compatible with the kubeadm version that I'm working with. So if I run this command kubectl apply -f, here I'm not mentioning any version. So it says CoreOS Flannel master documentation cube-flannel.yml. So once you run this, so everything has been installed. Now if I run kubectl get nodes command, I should be able to see that all the nodes are in ready state. Sorry, I should have used kubectl. So now if you see, all the nodes are in ready status. So there's no problem anymore. We can use the describe command again if you want to get a little bit more detail. Now here you are not seeing any more error messages. It is not saying that network plugin is not installed. It is saying that the node is ready. So the final status is node ready. The same should be shown for the worker nodes also. Let us go ahead and check one of the worker nodes. So the worker node is also fine. Kubelet is ready. It is posting ready status. Eventually see the event saying that node is in ready status. Kubelet is working on this worker node and status is ready. So finally we have managed to get our cluster up and running. Currently there are no pods, so no objects have been created. We'll do that in our next section, but we have all the nodes up and running. You can run this -o wide option to find out a little bit more detail. So it says that this is the first line, Kubernetes master, the status is ready, the role is ready, it is up and running for the last 26 minutes. This is the internal IP of this node. So these are the node IP addresses. As of now, there's no external IP, and the OS image is Red Hat 7 MIPO. It is also showing you the kernel version and the container runtime, which is Docker version 8.9. So we have created our Kubernetes cluster using kubeadm. One of the very important pieces which people miss is the network plugin. So make sure that you install the network plugin before you join the worker nodes. You can run this network plugin command after joining the worker nodes also, but you might get confused because if you run kubectl get nodes command, you will see that the status to be not ready. So run the network plugin command, either Flannel or Calico. I have used Flannel here. If you want, you can use Calico also, which I have not shown. So stick to Flannel because that is a command which has been mentioned in the resource section also. All these commands are there in the documentation of the resource section. So you can copy and paste those commands to create your own Kubernetes cluster. So going forward, we'll be using this cluster to create our objects like pods, services, etc.